Hey guys, today we're going to be looking at bivariate data and we're going to be comparing two different examples. First of all, bivariate data is a set of data that is made up of two paired variables, x and y. This relationship can be linear, where it has a constant rate of change or a slope, or nonlinear, where the rate changes or varies. It's not constant between the pairs of points. So let's look at this first example here. Paige wants to invest the $200 that she currently has. The first option earns a simple interest of 5% and the second option earns interest of 5% compounded annually. So we have simple and compound interest. The table and graph shows what will happen to her total amount over 20 years. I don't see any points on the graph, so we're going to go ahead and plot the points that we see from the table. So starting with the simple interest, at 0 years, she's starting with $200. At 5 years, $250. 10, $300. 15, $350. 20, $400. Okay, if you notice in general, these points do make a straight line. And then let's graph the compound interest. So at 0 years, she's starting with $200. At 5 years, 255.26. 10 years, 325. If you notice, it's a little above each time. 15 years, 415. And then 20 years, 530. So if you notice, this one was not a consistent rate of change, where the simple interest is. And let's show that a little bit more. So the simple interest, we can just count in our head, is adding, 50 each time? 200 plus 50, and then 250 plus 50. So each time it's only adding $50. Now, on the compound interest, I notice the first one added 55.26. The next one, let's subtract to see what happens. So 255.26 minus 325.78. And if you actually work that out, that would give us 70.52. Okay, so already right here it's different. Okay, if you were to subtract the next two numbers, 325 and then this 415, that would be adding $9.01. If you were to subtract these next two numbers, 415 and 530, that was adding 114.87. So again, to find the difference between the two, you would keep subtracting like we did with the first one. So the simple interest was adding 50 each time. That is a consistent rate of change. The compound interest is not going at a consistent rate of change. Its number is changing each time. So we'll just say that this is not constant. It's not linear. If it is constant, then it is linear. Okay, remember linear means a straight line, and then not constant means, like in this case, it's curving up a little bit. So So let's look at the last question. It says, what is the advantage of using compound interest to save money instead of simple interest? So if you don't know much about compound and simple interest, if you put your money into a bank and you want to save that money, in this case, the bank is paying her $50 for every 5 years. Now, if you notice and that was for simple interest. For the compound interest for every 5 years, I mean, the first time it went up 55.26, and then it was 70.52, and then $90.01. So her earnings from the bank keep going up and up as the years pass on. So the advantage of compound interest in this case is that it helps her money grow at a quicker rate. Okay, guys, that is comparing bivariate data. We were able to see one where it has a constant rate of change, and then another where it was not consistent and is not a linear relationship. Thank you guys for watching.